right, so let's talk about solving exponential equations, for which we have to recall a little bit of terminology.
Okay.
When there's a number and a little number written above it, to the right, what do we call this one?
That's a superscript.
That's the base.
Base.
And this little guy
That's an area.
is an exponent, right? Okay, let me start this by a really easy example. Okay? Easiest one I could come up with.
Okay.
3 to the x is 9. What's x?
2.
2?
What?
Yeah. I think it's 2 over 1.
Okay, can someone explain to me how they did this?
Because 3 times 3 is 9. 3 squared.
Yeah.
Okay, how does 3 times 3 is 9 explain this to us?
3 to the second power or exponent?
Yeah, 3 to the second power is 3 squared is 3 times 3, right, which is 9. Another acceptable method is duh, right? You all realize this without thinking very hard. So I'd like to kind of codify what you were thinking. And this is because these get a little more complicated. So the first thing I would do is say, okay, 9 is, well, I'm looking for 3 to the x, right? So how would I think about 9 that would help me?
How many 3s?
Yeah, I want to think how many 3's make up 9. So I might think 9 is 3 squared, right?
Right.
Yeah. And then those two things probably have to go together. Why do they have to go together?
Because it's an equivalent.
Yeah, because the bases are the same. You guys see that? So because the bases are the same, really what the exponents are doing is telling us how many 3's there are. You guys see that? I don't, for instance, know any information from knowing that this is a 3 and this is a 9 with an exponent of 1. You guys see that? The bases are different, and so these two things have no like really obvious relationship. You guys see that? You want to try another slightly harder one to see if we can get a handle? How about 3 to the x is 1 over 9? Oh, yeah, probably. X is negative 2? Which you got by what?
By doing x squared times negative x.
So you said, okay, 9 is 3 squared.
9
And then-
is 3 squared, and then it's the opposite because it's negative. So you flip the signs.
Perfect. You guys remember that?
You
done too. Cool, thanks. So then we say what? Now that the bases are the same, what?
X is equal to negative.
Yeah, then the exponents have to agree, right? That's cool with this?
Cool. So this is
This is
10.
11.
Well,
But-
the negative exponents was in.
Chapter 9, section 5.
Okay.
Or 10, section 5. Chapter
Okay.
10, section 5. So, what else did we learn there? We learned about negative exponents. What else did we learn?
Fraction exponents.
Fraction exponents. So can you guys make up a problem like this that has fractions in it? Can anybody make one up fast?
4 equals like 1 over 16. It's like the same. And not equal to that.
Equals 1/16.
Like this?
Yeah.
4 to the x is 1 over 16. What's the solution to this?
It's negative 2.
So this is 1 over 4 squared, right? Which is 4 to the negative 2. And then the exponents have to agree, right? You guys see that? Does that have fraction in it? Yeah, that one didn't have a fraction in it. I want one with a fraction in it. You guys make up one with a fraction in it?
subtracting 27 to the 1/3.
27 to the 1/3 is, where's your x?
There you go. Sure, yeah, that'll work.
Maybe?
I don't know. I'm just saying numbers.
Okay, let's think about this one. So let's see. I want to leave the 3 to the x alone, right? What do I want to do with this left side to solve this thing? Yeah, I want to know how many 3's are there on the left side. So there's 3. What's 27? 3 cubed to the 1/3.
Yeah.
And then what do you do with the powers? So this is 3. Multiply them together so you get 1.
Mm-hmm.
So what's x?
1.
Crap. Still didn't get an answer that was a fraction. You guys want me to give you an easy one that has a fraction as an answer? Alright, how about this?
I got that backwards, I guess.
Yeah, you got it totally backwards. So you might think, okay, how about the cube root of 3 is 3 to the x?
So it would be 3
3
to the
to the 1/3.
Good. So that's 3 to the 1/3 power is 3 to the x, and then yeah, the x's have to be the same. So I find out that
X
x is 1/3.
Yay.
Okay, see that? Okay, so far these have been pretty chill. They get a little bit sketchy, right?
Sketchy.
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 I like the I.
Sketchy.
Sketchy. I'm feeling kind of
They get a little bit funny sometimes. In particular, when stuff like this happens.
What? Oh, 0.
Zero.
Okay, that one was easy. You guys all spot that one right off the bat?
Yeah. Oh,
Were you about to say
Ah.
negative 0?
Why is this mm?
Because the negative.
The negative, and then the
Yeah, because
1.
there's a negative. What am I kind of meaning by this?
Negative x.
2 multiplied by itself is a negative number.
Yeah. How many times do you multiply 2 together to get -1?
Not a lot.
You kind of don't. You kind of can't, right? You guys see that?
It's a toughie.
So this probably is just straight up like,
No. No solution, huh?
Yes.
nope,
No solid.
there's no solution. It's a trap, something like that.
No solve.
No solving this one. There ain't such an x.
I like that. Ain't such an X.
Ain't such an x. I suppose if we were really doing full
Ain't
quote,
such an
there ain't such an x. Okay. Aside from making fun of certain demographics,
Aren't you born?
why would there be a good reason for this? You just ask if there was something wrong with it.
No. It was worse than
So if you walk into a bank and you're like, how much money do I have? They're like 2 to the X, and I'm like, so -1? They're like, no. Then
Some weird people
Don't
story.
do
I'm not
that.
gonna lie.
You need to change banks.
Yeah.
Don't do that.
that'll be a hint.
So, although things like this actually do occur with money, these problems occur with interest, and they happen a little bit like this. It's good to know when they aren't solvable, because if you know when they aren't solvable, you can spot errors in spreadsheets. Aside from that, I would like to have an intuition for what's happening here. And my intuition doesn't do real well with this kind of algebraic thought, right? So let's see if we can figure out a graphical reason why this might be. You guys want to spend a second and figure it out? We have 2 minutes left. I think we can fit it.
Graphical.
So I want to give a graphical approach for that.
Okay.
So this is going to be about exponential functions for just a second. Okay? So the exponential function that I want to spend a second with is f of x is 2 to the x.
And x
So
has
it
to be.
kind of-
Please note that this is not x squared.
What would that?
So
Yeah,
f of
that's
x
the question we're gonna ask.
has to be -1.
But this is not x squared, right? You guys all see that? Yeah, although this has the same symbols and the same roles, they're interchanged, and that makes a big difference. So how do I graph a function that I don't know?
What's
So you're
your
not
order?
going
Choose for X, you have to know.
Yeah.
I want to know x's and 2 to the x's, right? And then I'm going to graph them. So I get my 5 favorite numbers out. And I plug them in. Which ones are easy?
0,
First.
1, and 2,
Okay, 2 to the 0 is 1. 2 to the 1 is 2.
and 4.
2 squared is 4. You guys see the geometric sequence?
And then you get 1/4 and 1/2. 1/2.
So you get a half here, right? And a quarter here.
Okay.
You guys see the geometric sequence that way?
Yeah. Oh
The big coat.
So this is kind of 2 geometric sequences, right? There's one that goes that way, and there's kind of another one that goes that way. That's why we talked about geometric sequences first, so that we could all see what's happening. That makes graphing this super, super easy. Because it has the point 0, 1 on it, right? So I go over 0, up 1. There's my little dot. Then I want to go to 1, 2. Then I want to go to 2, 4. So as I go 1 to the right, what happens to the y value? Remember, this part's a geometric sequence.
It gets twice as big.
Yeah, so I go over 1 and it goes twice as high. So I go over 1 and I get to 2. I go over 1 more and I get to 4. I go over 1 more and I need to go twice that high. See this? If I go left, what happens?
Twice
Much
as small.
slower.
Yeah, it gets half as high.
Look at the wee little guy. Oh,
You guys see what's going on there? Is it ever going to hit 0?
No, because you keep dividing by halves.
Yeah, I keep dividing by halves, so I'll never get to 0. But it does get really, really little. So I've got a function that looks kind of like this.
You can never reach -1 because you can't go past 0.
You guys see that?
You can get smaller than
Bam.
And story says,
You get smaller than -1.
I can never reach -1, which is right here, right? That's the function -1. The black and the red never hit, right? You guys see that?
Ain't no such an X.
So there ain't no such x.
Oh,
Oh.
cool.
You guys see that? Because that would be asking, what input, right, into the 2x function gives you the same as -1?
Yeah.
Well, there isn't an input that gives you negative anything, much less -1.
Sexy.
You guys see that? So the use for these is populations, right?
You can't have
That's how
negative
you
people.
have
Like negative population.
Yeah,
Okay.
negative populations don't make sense, right?
You could lose
Yeah,
all of the
that
population.
Is
You
that
can't do
like-
it. You gotta get it.
And then you
There's
start
two.
jumping.
Yeah, there's
They go,
three,
whoa.
four pictures.
You guys cool with this? Any questions?
Okay.
Okay.
We talk about